Hello again, Chem 2, and welcome to the second part of section 4.1. Now we're going to do the math part, the part that deals with the stoichiometry aspect. In chapter 3, we dealt with a lot of stoichiometry. We talked about moles and mass, and we saw this chart a lot. You could start with volume. If it was a gas at STP, you could start with mass. You could start with particles, maybe. You could start with moles. And if given that information about those substances, you could figure out the exact same quantifiable measurements of a different substance within a balanced chemical equation. But not all substances are solids, liquids, or gases. What if they are dissolved in water? What if the materials are dissolved in water, just like we saw in the previous video where we talked about reactions that took place that maybe were precipitation reactions. Well, now what we're going to deal with is we're going to talk about solutions that are mixed together, and we're going to take some volume of a certain molarity solution. So now we've dissolved in this case, it's iron nitrate into some solution, and we're going to combine it with sodium hydroxide, and we're going to make an iron hydroxide precipitate. And the question would be, what volume of that 0.136 molar solution is going to be needed if we want to make 0.886 grams of precipitate? So our starting point is our 0.886 grams of precipitate. Well, now we got to figure out how to get moles another way. Well, we already know that molarity is moles per liter. Moles per liter. So that it turns out to be a bridge, a conversion factor per se, to go between moles and volume and molarity. Buckle your seatbelts. Our new mole chart looks like this, where we can be given volume and molarity of some solution, and that can give us the number of moles, because volume times molarity will give you moles. If once we have moles, we're asked for the volume of some solution we know the molarity of, we can take moles divided by molarity and get volume. If we have moles through a stoichiometric calculation and we also know the volume, then we can get the molarity. So what we're doing in this situation of the example problem that we have on the previous slide is we're given a mass and it's asking for a volume. So we're going to go use the molar mass, the balanced chemical equation, and now we're going to use moles divided by molarity to determine the volume of the solution. So we're given the ionic equation, we can determine it. We're given the mass, we're given the concentration of the iron nitrate that we're being asked the volume of, and then we're supposed to find out the volume of that iron nitrate that was used. So we're going to go from mass to moles. So the mass of the precipitate times the moles of precipitate, then use the balanced equation to get the moles of the ion, then get the moles of the parent compound, and then finally get the volume. So in order to get the moles of iron nitrate, we're going to take our grams divided by the molar mass to get number of moles. Then we're going to say there's one iron in an iron hydroxide, and there's one iron in an iron nitrate. So how many iron nitrates do we need? If we know the number of moles of iron nitrate we have, which is 0.00829 is how many we need to make the 0.886 grams, we need 0.00829 moles of iron nitrate. Well, we know that our solution, our concentration of our solution of iron nitrate is 0.136. Do the math, we find out we need 0.0610 liters or 61 milliliters. Okay, so we know that we need 61 milliliters of our solution in order to make that happen. That is a way to use stoichiometry to determine the concentration of, or the amount, the volume of the solution. You can use molarity, knowing there's moles per liter. If you've got two of the three, you can get the third one. And that's it, okay? Probably should add that into the last video. We're going to do a lot more of these practices in class of how to use this. This is actually the crux, the rub of everything. And actually, there's a lot more common version of this stoichiometry in the acid-base reactions, which we'll do in the next video, where we will look most specifically at acid-base reactions, when we have an acid reacting with a base in very special circumstances to come together and make very special, routine, predictable compounds, much like the precipitates were very predictable compounds, and do some stoichiometry with it. So until next time, stay safe, stay healthy, practice social distancing, and this video should have been tacked on to the last one. Toodles.